So here you'll be seeing the signal strengths, like signal strength and the quality. So here is the number of the satellites, okay, and here is the signal strength. Now it is one satellite being in track and it's in gray. It's not being used for the solution. When it turns blue, these will be the satellites that are being used for the position fix. Okay. So this is now it is collecting the almanac data and setting up for the position fix. Here you will be seeing the azimuths, okay, azimuths and elevation. This is the azimuth and elevation window. You will be seeing the satellites. So let's say that you're on the center of this circle, and this is your horizon. You're seeing the satellites in the sky, the ones that are visible. Okay, you'll be seeing them here. Okay, and this is just the journey. You'll be seeing the graphical journey of the position here. So this side is not really important for us. We're interested in seeing the altitude here, how it will be fluctuating, and then you will have your conclusions, the accuracy or the
and this is the first satellite, right?
Yeah, so you have to observe here when it changes. That's when you click stop, and then this will be our time of the cold start. So yeah, you will see the satellite in the sky. We will be observing this area here to see the time of this cold start. How many minutes at this moment?
2 minutes 12 seconds.
Okay, so now,
Okay.
did you stop it?
Mm-hmm.
It's still ready.
I took the.
Okay, all right. So that's about two minutes. Yeah. So you have that in mind. So when we do the hot start, that you will do your you will have your conclusions. The difference between the cold start and the hot start. So at this moment, pretty much 132 meters. Okay, for this kind of old receiver, it's not bad having this value close to the real altitude of the elevation of the antenna, 135 meters.
Where is the antenna?
It's mounted on the roof, above sea level. Okay. All right, and then what are we seeing here? So these are the satellites here. The ones in blue are the satellite being used for the solutions. The higher the value of the signals, the better. But these ones in blue, as long as it's in blue, it is being used for the localization. Okay, you have the PRN, the pseudo random number, which is the unique number, identifier number for a satellite. And you have the azimuth, the direction of the satellite, and then the elevation of the satellite. Okay. Now, before it was 131, now it's getting to pretty much close to the real elevation of the antenna. Okay. What could be the assumptions at this moment between this GPS receiver and the GPS receiver from your phone?
The differences?
Yeah, what is the conclusions or assumption you may have in your mind? Imagine the GPS that you have in your phone and this GPS here.
We don't usually have cold start in phones. Usually there's some data saved and then we'll get the hot start. We don't have to wait a couple of minutes.
And why is that?
Because it's faster and usually
If it's faster, but why is it faster?
it uses triangulation.
From GSMs.
Mm-hmm. And what else? All right, so you have also the GLONASS data information in your phone, and also Bluetooth and Wi-Fi. So with that, it is faster on your phone for easier localization. But here it's only using GSM system.